Okay, the circle C with center minus 2, 6 passes through the point 10, 11. So I'm going to just sketch that, okay, roughly. So let's say the circle center minus 2, 6 is here, and then 10, 11. Let's say this is 10, 11. Okay, and another show that the circle C also passes through the point 10, 1. So I'm going to label this as 10, 1. Okay, if you read the question carefully, it says the circle passes through these two coordinates. So it has to be on the coordinates must be on the circle. So therefore, if I want to find the radius, what I can do, I can take 10, 11 and the center, which is minus 2, 6, then find the distance, use the distance formula to find the length or the distance between the center and the point on the circle. In this case is 10 and 11, so let's use that. So if I take x2 minus x1, which is 10 minus 2, okay, 10 minus 2 square plus 11 minus 6 square, okay, x1 minus x2 square, and then y1 minus y2 square. Okay, so this would give me, that is 10 plus 2, which is 12 square, and then plus 11 minus 6 is 5 square. So clearly this gives you a quadratic, this gives you a Pythagoras triplean, okay, which is 5, 12 and 13. So this is 144 plus 25, that gives me square root of 169, and the answer is 13. Okay, so the radius is 13. Okay, show that the circle passes through 10, 1. So if I take form the equation, let's say x minus x1, the center, negative 2 square, plus y minus 6 square, this should be 169. And if it passes through the coordinate, change color, okay, if it passes through another coordinate which is 10, 11, what I can do, I can sub here x plus 2 square plus y minus 6 square equals to 169. I take x10 and y1, sub inside, and see if I'm getting 169. So it should be 10 plus 2 square, okay, this is x and this is y, and then plus y 1 minus 6 square. So this would give me what is that, 112 square plus 1 minus 5, which is 5 square, and this is 144 plus 25, and this is equal to 169. Therefore yes, 10, that's shown that C, the point 10, 1 is on the circle. Okay, that's for part A, done. For part B, the tangent to the circle at point 10, 11 meets the y-axis at P. Okay, the tangent at the point 10, 11 meets the y-axis at P. So first of all, 10, 11, okay, this is fine. Let's say this is the tangent, okay, at 10, 11. Okay, so I have to find what's the gradient of this tangent. Okay, if I extend this tangent, and the next one is for 10, 11. If I extend this tangent, both, okay, the diagram is not accurate, but I'm just giving you an idea. But let's say they are not parallel, they just keep, if I extend those 2 points, those 2 points will meet at different parts on y-axis. One will meet at P, okay, for the first one. Then for the second one, it will meet at Q, okay, on the y-axis. So I have to find the equation. So before I find the equation, I need to know what is the equation of the gradient for this line, which is the radius, okay, between the tangent, okay, and the center. So let's do that. So M1 will be y2 minus y1, so 6 minus 11 over minus 2 minus 10. So this is minus 5 over negative 12, and the answer is 5 over positive 12. If this gradient is 5 over 12, then the tangent gradient should be the reciprocal with the opposite sign. Okay, so the gradient for tangent, okay, at P, or I'll just write tangent P, is minus 12 over 5. So let's form the equation. Use the y equals to mx plus c, y equals to mx plus c. So we can form the equation. So use 10, the coordinate 10, 11. So when y equals to 11, m equals to negative 12 over 5, and then times by x, which is 10, plus c. So therefore this is 2. So 11 equals to negative 24 plus c, therefore c equals to 11 plus 24, which is 35. So the equation of the tangent is y equals to negative 12 over 5 plus 35. Okay, done. Now this line cuts at y-axis at it cuts at y-axis at P. So when a line cuts at y-axis, minus 12 over 5x, when a line cuts at y-axis, x equals to 0. So therefore y equals to 0 plus 35, which is just 35. So the coordinate is 0, 35. Okay, this is for P. Okay, now let's find the equation of the second line. Okay, we have another line that cuts that passing or cutting the y-axis at Q. So we have to find the equation of that. So before that, we have to find what is the gradient from the center to which is the radius. Okay, from the center minus 2 to 6 to 10, 1. So let's do that. So 10, 1 minus 2, 6. So y2 minus y1, 6 minus 1 over negative 2 minus 10. So that is 5 over minus 12. Therefore, this is the gradient for the line from the center to 10, 1. So the tangent gradient should be the reciprocal with the opposite sign. So the gradient for tangent at Q would be positive 12 over 5. Now use the coordinate 10, 1, and then form the equation. So y equals to mx plus c, where y is 1, m is 12 over 5, and x equals to 10. Then from there you can find what is c. So this is 2. 12 times 2 is 24. 1 minus 24 equals to c, therefore c equals to minus 23. So the equation of tangent is y equals to 12 over 5x minus 23. Okay, now find the coordinate of Q when the when the line cuts at y-axis. So when a line cuts at y-axis, x becomes 0. So when x is 0, y equals to 12 over 5 times 0 minus 23. Okay, minus 23. Therefore, y equals to negative 23. Okay, negative 23. Okay, so we have two coordinates, P 0, 35, Q 0, minus 23. And for B, show that PQ is 58, explaining your method clearly. Okay, 58. So now to find the distance of PQ, so x2 minus x1, so 0 minus 0 square, plus y2 minus y1, so negative 23 minus 35, you square that. So your answer is, this is 0 square, which is 0, plus minus 23 minus 35, that's minus 58. Okay, minus 58 square. Okay, so minus 58 square, you square root you square that, you get such a big number, which is, okay, let me do that. 58 times 58, I got 3000 positive 3364. Okay, and you square root that, it goes back to 58. Okay, so therefore the distance is 58, and as we require to show, it is shown.